Okay, welcome everyone to our presentation of our project called Resilient Decentralized Computing. And in this project, we're trying to radically innovate smart edge services to enable trust and simplicity. This project is a joint research pair project with my colleague Paris Carbone and our PhD student Jonas Spenger. And this project focuses on three core aspects of decentralized data services, in particular trust. So the key is to provide really high trust in our systems by first making them resilient to failures and also to ensure consistent processing of data and operations on the data. And we also want to ensure high data protection guarantees and automate the compliance with regulation like GDPR. Then second, we want to provide a declarative programming interface that makes it much simpler to build distributed systems. And also, it's important to enable to build systems in a modular way so that we can flexibly exchange implementations and evolve the systems, and to enable kind of using services as a utility, which is one core aspect of serverless computing. And finally, of course, we want to provide high performance in the sense of very low latency by processing data on the edge, very close to where the data is produced and consumed, and to ensure also high scalability, which is an effect of decentralization. Yeah, now the modern data services are actually highly complex systems. So to build a service, one needs to typically combine multiple systems, right? So each of these gray boxes is a sophisticated distributed system itself. And each of those is a potential point of failure and needs to be considered to ensure data protection. What's worse is that user data is typically distributed across all of these systems, right? So being compliant with GDPR is actually very difficult problem. And so the core question is, can we really expect software developers to build systems that satisfy all of these requirements? For example, for scalability and reliability, right? Where we need to make sure we can be resilient to failures. And while at the same time, providing low latency, supporting decentralized execution across cloud and edge. And as I mentioned, being compliant with data protection regulations. And finally, of course, one challenge is building systems that provide privacy-preserving computation, right? And we argue that we are actually demanding too much of software developers today, and we need to radically innovate in the systems that we use to build modern data services. Yeah, and there's plenty of evidence that we are indeed requiring too much of software developers, because even the biggest tech giants have big problems ensuring data privacy. So we read about data privacy scandals, for example, at Facebook, where user data was shared with third parties, even though it was supposed to expire. And these are, of course, violations of regulations such as GDPR.
Now, if we look how people today try to implement this type of distributed decentralized services, they will have to rely on different types of systems based on the properties that they get. So when it comes to reliability, the optimal choice today is data flow systems or data flow streaming systems. Those are the systems you see on the top, and these types of systems are very, very fault tolerant. So they allow you to define, scalable logic that has state, and it can run 24/7 without any disruptions. But at the same time, data flow systems are not flexible. So what this means is that one cannot really extend data flow systems with additional logic or build services from existing services in a seamless way. So they are definitely not flexible to extend and build more complex logic over time. And that's why a lot of effort today boils down to using actor frameworks. Actor frameworks is another key technology we work in our group, and Philip is one of the key innovators with actor frameworks. The point of actor frameworks is to be flexible, right? So they allow programmers to build in a more organic way decentralized programs, and they use message passing, and really they're really easy to spawn new programs and things like that. So they are simple and flexible, but at the same time, they don't really give you any built-in guarantees. They don't give you any fault tolerance or data processing consistency guarantees. This is something that has to be implemented by the user, and it's very complex. That is why we came up together, Philip and me, with the idea of portals, because portals, in essence, combine the nice attributes of data flow systems with the flexibility that you get from the actor model. And we put this in the context of services that run across edge and cloud. Now, the missing part, the key missing part to enable this type of trust across edge and cloud is implemented through this notion of portals that allows this integration of logic and services across different locations, let's say. And at the same time, we enable fault tolerance and exactly once guarantees when it comes to processing across these workflows. If you look into portals, portals enable simplicity effectively via the use of these programming abstractions we call portals. So this is a programming abstraction that can, in fact, substitute the need for actors when it comes to flexible communication, because they allow any task from any workflow running anywhere to send requests to other workflows that run somewhere else. And that can happen anywhere between an edge device and a very scalable cloud service. At the same time, the API that we expose to the user, the program model, is very simple. So it's as simple as just doing an asynchronous call, function call in a functional programming language. Now, the glue between workflows and the way we let computation happen across portals is through atomic streams. And atomic streams are one of the underlying mechanisms we created that enforce the following. So we have this division of computation and data into atoms, and atoms are predefined. They travel over the network and across workflows, and they actually enforce consuming workflows to process atoms transactionally. So that means that they cannot really proceed unless they process each atom transactionally and generate side effects. Now, the order of atoms also can be used to guarantee serializability. So we can serialize operations and validate, for example, GDPR operations across workflows. So this is very important because also at the same time we enable both data protection and fault tolerance.
Right. And now one interesting aspect of portals is, as Paris mentioned, the flexibility in terms of the programming model that's provided to the developers, right? And so what we did is a study of existing programming models to see, okay, which programming patterns and communication patterns they actually support, and also which processing guarantees and other features, for example, data parallelism, task parallelism, and so on. And the portals model is innovative because it can actually unify several existing models, right? So it supports the data flow composition of data flow streaming systems with communication patterns like request reply, which is known from the actor model. And importantly, we can provide guarantees such as serializable updates, which again are important to enforce data privacy regulations. Yeah, so the next steps for our project is to investigate built-in privacy in terms of, for example, secure multi-party computation, and also sort of increased safety with static analysis methods. And then in terms of edge and cloud deployments, we want to look into decentralized resource management, and also elasticity, meaning the use of resources can be scaled up and down on demand. And then an important part of our project is to work on demonstrators and case studies together with our industry partners. And we're in the process of starting collaborations with more and more industry partners here in Sweden. But of course, the project has also global impact opportunities. And this is enabled by the development as an open source project. So we're trying to build an open source community around the Portals project as well. Yeah, with this, I thank you for your attention. And you're welcome to, in fact, visit the project website. And if you're interested, you can sign up to a newsletter where you can be informed when there's the release of Portals as a public open source project.